Alright, in this video we're going to solve first order linear differential equations. So let's look and see what a first order linear differential equation is. So a first order linear differential equation is an equation of the form dy dx plus p of x times y equals f of x. P and f are continuous functions of x, and this this is considered to be in standard form. Okay, so to solve one, you have to get it in this form, and we have the dy dx, but you know that this can also, the dy dx, it can be written as y prime. Okay, so let's look and see how to solve one. See what we have to do. So the solution of a first order linear differential equation, so to solve a linear first order equation, first put it into standard form. So that means that we need to get it in this form right here. Okay, that's the form we need to get it in. Then we need to identify p of x and find our integrating factor. So our integrating factor is e raised to the integral p of x dx. And then once we find our integrating factor, we multiply the equation obtained in step 1, so the standard form, we multiply it by the integrating factor, and that's what that would look like there. You multiply each term by the integrating factor. Now, the left side of the equation in step 3, that would be this part right here, okay, and the y is included. Okay, so the left side in step 3 is the derivative of the product of the integrating factor and the dependent variable y. Okay, so we take the integrating factor times y, and the derivative of that would be this left hand side, and that equals the integrating factor times f of x, and then we just simply integrate both sides. Okay, alright, so let's take a look at a couple of examples. I'm going to erase what I have here, what I've written on here. Alright, so let's take a look at our first example. So we want to find the general solution. So the first thing we need to do is just like step 1 says, we need to get it in standard form. So we want the coefficient of y prime. See, and remember, y prime, that's the same thing as dy dx. So we want this coefficient to be 1. So what I'm going to need to do is divide everything by x, and that will give me y prime minus 2 over x times y equals x. Now you can see that I have it in the standard form. Y prime minus p of x y equals f of x, and you can see the p of x is the part in front of y. So we know in this problem that p of x is equal to negative 2 over x. Alright, so now we need to find our integrating factor. And remember, our integrating factor is e raised to the integral px times dx. So what I'm going to do is I'm just going to go ahead and I'm going to evaluate this integral right here. Okay. So I have the integral of p of x dx is equal to the integral of negative 2 over x. See, p of x is negative 2 over x dx. And that is equal to negative 2 times the natural log of x. Okay, and you should know that integral there. And so this is equal to negative natural log x squared. Remember your logarithmic properties. This right here, this we can pull up. Okay, the 2 we can pull it up into that exponent there. So that tells us that e raised to the integral p of x dx is equal to e raised to the, and then the integral of p of x dx is negative natural log x squared. So let's go ahead and kind of clean this up a little bit. That's going to give us 1 over e to the natural log x squared, which is equal to 1 over x squared. If you remember, see, the base here is e and the base of natural log is e, so when those are the same by your logarithmic properties, it's just your answer is what you're taking the log of, which is x squared in this case. Alright, so we found our integrating factor. Okay, this is our integrating factor. Now, remember what the next step says to do? Let's go back and look. Okay, so we identified p of x and we found our integrating factor. Now we multiply the equation obtained in step 1, so that's the equation that's in standard form. We multiply it by the integrating factor. So let's go ahead and do that. Alright, so the equation we got in step 1 would be this right here. So that's going to be y prime minus 2 over x y equals x, and we're multiplying that by the integrating factor, which is 1 over x squared. Okay. So when I distribute this, I'm going to get y prime over x squared minus 2 over x cubed y equals 1 over x. Okay, that's what I get when I distribute it to each term. Alright, so now let's go and look at the next step. Alright, so I multiplied the standard form by the integrating factor. So now it tells me the left side of this equation, okay, is the derivative of the product of the integrating factor and the dependent variable y. Okay. Alright, so let's see what we have here. So that's going to give us the derivative with respect to x of y over x squared equals 1 over x. Alright, so basically what it is this left-hand side of the equation here, okay, is the derivative of this, okay, is the derivative of y, is the derivative of the product of y and the integrating factor. So I took y times the integrating factor, which gives me y over x squared, and it's the derivative of that. And we can verify it. If we take the derivative of this thing, well, what do we get? It's the derivative of the numerator, which is y prime, okay, times what? Times the denominator, okay, minus the derivative of the denominator times the numerator. And that's all over this denominator squared. So that would be, oh, I'm sorry, that would be x to the fourth. And then you can see if we split this up, we get y prime x squared over x to the fourth minus 2xy over x to the fourth. And then you can see that this simplifies to y prime over x squared minus, and then the x and x to the fourth cancel. That's 2 over x cubed times y. That gives us this side here. Okay, that's where that comes from. Alright, so let me go ahead and get this off. Alright, and then if you remember, the last step, step 5, says to just integrate both sides. Alright, I'm going to erase that. So let's just integrate both sides. And so if I integrate this, well, that's just going to give me y over x squared equals, and then the integral of 1 over x, that's going to be the natural log absolute value of x plus c. And then I solve it for y, so I'm going to multiply through by x squared. Okay, I'll multiply everything through by x squared, and so that's going to give me y equals x squared times the natural log absolute value of x plus x squared times c. And this would be our answer. Alright, so I hope this video helped. I'll probably do 1 or 2 more videos, so you can check those out. I'll do 1 or 2 more videos of this type of problem, and hope you'll check out my other videos. Alright, thanks.